Here we're asked to find the equation of the tangent line to f of x equals 3 over root x at the point 9, 1. So this is a very typical question. They ask us to find a line that comes down and lightly touches or is tangent to the curve. That means it touches at one point and even a slope agrees at that point. And they provide us a function and they provide us a point. So now let's remember to find the equation of any line, we need two things, and you remember this from your old algebra classes. First of all, you need a point on that line. It's nice if it's the y-intercept, but we can get around that even if it's not the y-intercept. And another important thing is you have to have the slope of the line. So if we can find these two things for our tangent line, we'll have this equation. So if we look at what's given, one thing that's typically always given is the point, because they have to tell you where where the point of tangency is. So in this graph, roughly 9 comma 1 right here, here's the graph of f. Here's the point of tangency, and the equation of the line is going to look something kind of like that. It's not a great graph, but you get the idea. So we have the point, but now how do we find the slope of this line? Well, remember the tangent line has the same slope as the curve at that point. So now how do we find the slope of curves? Well, that's what we've been studying in calculus. Derivatives tell us the slope of a curve at a particular point. So a good 60-70% of this problem actually doesn't have anything to do immediately with tangent lines. It has to do with finding a derivative of a function to get the tangent line's slope. So let's take a minute and do that. Okay, so here's f of x. F of x is 3 over root x, and I want a slope. So I need to take his derivative. So what would be the derivative of f of x here? Well, as we often have to do, we'll probably want to rewrite this so that it fits one of our shortcut rules: product rule, quotient rule, chain rule, power rule, one of those guys. And notice, being that this is in the denominator, if we express it as 3x to the minus 1/2, then that very nicely fits the power rule, right? It's 3x to a power. So the power rule says bring the exponent down. We get negative 3/2 x to the, and then we subtract 1 from the exponent, which would be negative 3/2. We'll put this negative exponent term back in the denominator because it has a negative exponent. Negative 3 over 2 x to the 3/2. Right now, this is important. This is a common mistake I see sometimes from students. This is not the slope, the m, that I'm looking for y equals mx plus b. Because notice, if you plug this in for your m and y equals mx plus b, the equation wouldn't be linear. You wouldn't have a line because this has a crazy exponent. See what this is doing, the derivative, is it gives you the slope at any x value, but we haven't specified our point of tangency yet. So to get our slope, we actually have to use this point right here. Now, you have a 9 and you have a 1. The 9 is obviously the x, and the 1 is obviously y. So do we have to plug in 1 or both of those, or how does it work? Well, notice the derivative only depends on x, so we will need to plug in the 9, but the 1 is not necessary. Now, I'm not going to go into a lot of detail right now as to why, but in short, I'll say that functions pass the vertical line test, so every x only has one y anyways, and so there's no reason to specify a particular y. It's understood that there's only going to be one y anyways. Now, if you had something that was not a function, like a circle that didn't pass the vertical line test, its derivative, if you used implicit differentiation, would use the x and the y both, but that's not what we're using here. So just the 9 is sufficient. So we'd have negative 3 over 2 times 9 to the 3/2. All right, a little arithmetic here. 9 to the 3/2 is the first thing we probably want to look at. Now, 9 to the 3/2 sounds confusing, but you can break it up into two pieces. You can say 9 cubed raised to the 1/2 power, because power to a power multiplies. That's a property of exponents. Or you could say 9 to the 1/2 to the third. And I think that's probably going to be easiest. 9 to the 1/2 is the square root of 9. That's 3. and 3 cubed makes 27. So 27 times 2 is 54. And so we've got negative 3 over 54, which will make negative 1 over 18. So that's our slope. And if we compare this to the graph of f, that seems very reasonable. Having a slope of negative 1 over 18 is practically zero. It's negative, it's decreasing, but it's very, very flat. So I think we're on the right track here. So last step is to write our final answer. I have the point and I have the slope. So from here on out, there's no calculus. There's no calculus involved. It's all algebra and arithmetic. There's two ways to write equations of lines, y equals mx plus b. That's probably the more well-known, that's slope-intercept form. But there's also a better form for when you're writing tangent lines. It's y minus y1 equals m parentheses x minus x1. And this is the equation of a line who has a slope of m and contains any generic point x1, y1. Now, why is slope-intercept form not the best thing to use always? Well, because it assumes that you have the y-intercept, but the point that you have might not be on the y-axis. Like, look at our point. Our point 9, 1, that wasn't on the y-axis, so it wouldn't be a y-intercept. Now, there are ways to kind of go in a roundabout way to find b. I'm not saying we can't use the slope-intercept form. I'm just saying this is probably a little easier. So we'd have y minus 1 equals negative 1 over 18 x minus 9. If you see what I did there, I plugged in the x, y value we were provided, 9, 1. Make sure you don't swap those incorrectly. Don't say 9 and a 1. Make sure it's a 1 and a 9, where the y goes with y and the x goes with x. And then the slope is negative 1 over 18. Now, what we'll typically do is we'll use point slope form like this to get our original equation of the tangent line, but then we'll use some algebra to kind of clean it up a little bit. So y minus 1 equals negative 1 over 18x plus 1/2. Negative times a negative is a positive. 9 over 18 makes a half. And then final answer, y equals negative 1 over 18x. Add 1 to the right, you get plus 3/2 instead of 1/2. So this is the equation of the tangent line in slope-intercept form, and it seems very, very reasonable, especially when I compare it to the graph. Matter of fact, I will graph this, and here's the graph that we get, and sure enough, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. See, 9, 1 right here. Looks like the point of tangency. Here's F, and then sure enough, the tangent line really is tangent to it. It lightly comes down and touches it. So I'm 100% we've got the right answer.